Thank you, Leah and Tony, for all the prep work, and it's a delight to be here today. As Leah mentioned, I've been studying high-performing technology organizations since 1999, and that was a journey that started back when I was a CTO and founder of a company called Tripwire in the information security and compliance space. In this study of high performers, we want to understand and study these amazing organizations that simultaneously had the best project due date performance in development, the best operational stability and reliability in ops, and the best posture of security and compliance, so that we can understand how other organizations could make those amazing transformations. And so in a 25-year journey, there are many surprises, but by far the biggest was how it took me into the middle of the DevOps movement, which I think is still so urgent and important. The last time that I think we've seen any industry being disrupted to the extent that all our industries are being disrupted today, in every industry, is likely manufacturing in the 1980s, when it was upended in the United States with the entrance of Toyota to the domestic automotive marketplace. And so it was just, I can't overstate just how much I've learned since the Phoenix Project came out in 2013. In fact, I even have a slide on this. So Lee, if you could just confirm that I'm sharing my screen. Share screen. All right, here we go. Yeah, do you see my screen?
Yep, I can see it here, G.
Oh, perfect. Okay, great. Yeah, so I wrote a book called The Phoenix Project, and after that came the DevOps Handbook, Accelerate, and the Unicorn Project, which was actually the last time that I was here among this group. And I'd love to share with you what I've been working on for the last 3 years, which was working with Dr. Stephen Spear from the MIT Sloan School of Business. And I had mentioned Toyota. So Dr. Spear was one of the second generation of researchers who studied deeply the Toyota production process. And so he wrote one of the most famous Harvard Business Review articles of all time called Decoding the DNA of the Toyota Production System. And so we've been seeking out what is in common between Agile, DevOps, Toyota Production System, Lean, and for that matter, safety culture, resilience engineering, and so much more. So this has been, without a doubt, the most challenging intellectual pursuit I've ever done in my career, but also the most rewarding. So I'll tell you, before I go into that, let me tell you a little bit about some terms that we use in DevOps and what I plan to do in this presentation. So as I had mentioned in 2019, the definition that we put into the DevOps Handbook was this. It is the architectural practices, technical practices, and cultural norms that allow us to deliver applications and services quickly and safely. So those are the conditions that allow for rapid experimentation and innovation, the delivery of fastest possible delivery to our customers, without sacrificing security, reliability, or stability. And so why do we care about that? It's so that we can win in the marketplace. And so my friend John Smart, who lives in London, he has a better definition that's shorter. And his definition is simply this: it's better value, sooner, safer, and happier. And I love this because it's not only shorter, but it's so difficult to object to. I think even your biggest DevOps skeptic would not say that they want less value later with more danger and more misery. And I think that really does such a wonderful job in articulating what we are trying to do when we say we want to do things in a more DevOps-like way. So one of the things I've had the privilege of doing for the last decade is running the DevOps Enterprise Summit. It's now been renamed the Enterprise Technology Leadership Summit. And so we've had 20 events over the last 10 years with over 1,500 leaders from over 600 enterprises, not from the tech giants, the Facebook, Amazons, Netflix, Googles, Microsoft, but some of the best known brands across every industry vertical, showing that we can use those same principles and practices in organizations been around for decades or even centuries. A particular point of real pride for me was that one of the organizations I presented was Barclays, which was founded in the year 1695, which predates the invention of paper cash. But the oldest organization that presented was also another UK organization, UK HMRC, which was founded in the year 1200. So even though there's no code that goes that far back, there was without a doubt values, traditions, and maybe even processes that go back centuries. So what I'm going to do today is share with you some of the biggest aha moments of my career and how some of it culminated in the last 3 years working on this book. I'll talk about the state of DevOps research findings and what some of the key predictors are. And I'll talk about modularity and amplification and culture, and show how they show up in the wiring the winning organization constructs, and go through the specific mechanisms and hopefully give you a glimpse of why these mechanisms work that we're so familiar with within the DevOps community. So First off, let's talk about like why DevOps is so why it creates business value. So one of the things that I've been most proud of is my work with Dr. Nicole Forsgren and Jez Humble on the state of DevOps research. So it's a cross-population study that spanned over 36,000 respondents over 6 years. And what we found was that high performers exist and they massively outperform their non-high performing peers. So it's measured by what? We know that these high performers are deploying more frequently, multiple times a day, 2 orders of magnitude more frequently than their peers. But more importantly, they can deploy more frequently. They can deploy, meaning they can go from code committed to version control, through integration, through testing, through deployment. So customers saying thank you in 1 hour or less. Again, 2 orders of magnitude faster than their peers. They are 7 times more likely to succeed without causing a Sev1 outage, a service impairment, a security breach, or a compliance failure. And when something bad happens, they can fix it in 1 hour or less, as measured by the mean time to restore service. That's 3 orders of magnitude more quickly than the peers. And so in the latest state of DevOps research, they now call this mean time to recover from deployment failures, which I think is a great clarification. And so it really just confirms that something that we've known for decades is that, the way that you get these amazing reliability profiles is to do smaller deployments more frequently. We looked at other dimensions of quality. We know that because information security objectives is being integrated into everyone's daily work, they spend only 1/2 the amount of time remediating security issues. And across organizational performance, these amazing organizations, as well as having great performance technology measures, they're twice as likely to exceed profitability, market share, and productivity goals. And, for not-for-profits, government agencies like UK HMRC, they're twice as likely to achieve organizational and mission goals, regardless of how they measure it, whether it's customer satisfaction, quantity, or quality. So there's other markers of organizational performance like this. They're twice as likely to have employees recommend their organizations as a great place to work. And so as with Linux Recruit, right, we know that no one wants to work in organizations where everything's difficult, where even doing small things requires superheroic efforts. It's not great for the organization, not great for the employees who work within those organizations. And so beyond those numbers, what does this suggest? It says, DevOps helps us quickly, safely, reliably, securely achieve all the goals, dreams, and aspirations of the organizations that we serve. So let me tie this into the work that I've been doing for the last 3 years. I had mentioned Dr. Stephen Spear. Here's a picture of him back in 2014 when I took a workshop from him at MIT. And I cannot tell you how much he has influenced my work. And so he started his work studying Toyota. He worked on the plant floor of a tier 1 Toyota supplier for 6 months. That decoding the DNA of the Toyota production system was actually based on his doctoral dissertation that he did at the Harvard Business School. And he went on to extend that work beyond just the high repetition work of manufacturing to engine design at Pratt & Whitney, to helping build a safety culture at Alcoa in the Alcoa melting, molding, that business. He studied the design and operations of all the naval reactors in the U.S. Navy seagoing fleet. And so the question that we set out to ask was, what is in common between what looked like very different things? Like, in the software world, we have Agile and then DevOps. In the manufacturing world, we have the Toyota production system and Lean. And we have these other things like team topologies, like West Conway's Law. We have resilience engineering. What is in common between them? And our conclusion is that they are all incomplete expressions of a far greater, but also far simpler whole, and that there's really these mechanisms that make all of these work, that the mechanisms are simplification, amplification, and slowification. They are all at work in these practices. So just to motivate that, let me describe, that in these high performers, not just in DevOps, but in, these high performers across all industries and all phases of value creation, there's this magic that these organizations have. So in the ideal, everyone's working and solving important problems all the time in parallel, that everyone has what they need, whether it's information, approvals, requirements, decision rights. They have it at the right time, in the right format, and they're interacting with all the right people. In the not ideal, it's the opposite. Everyone's stuck because no one has what they need to get what needs to get done. Even when they have it, it's not in the right format at the right time, and even small efforts require, super heroic efforts. And so here's an example that I heard last year that just so much resonated with me. A friend of mine from a mobile telco, he said, one of the top initiatives for the company is to get a checkbox presented to their 20 million customers to opt into a $5 a month service for like email or to watch movies. This requires work from 20 different teams. It requires over CEO minus one level support, daily war room meetings. It's estimated to cost $28 million. It will take 12 months to do. And most people give it a 20% chance of success because the last two times it failed. And so what's amazing here is that it is not the technology work that is the hard part. This is all in coordination and a small thing requiring the entire organization to be mobilized to get done. Another dimension of this magic is that in the ideal, we have energetic feedback loops where even the weakest failure signals are amplified and then acted upon quickly. People are constantly learning from fast feedback, and that the feedback is going to the right people, right, at the right time in an actionable format. It's not getting put into a logging system that only one person can access. In the not ideal, what's the opposite? It's that the feedbacks are weak, slow, or maybe even non-existent, and whatever feedback we have is going to the wrong people. So therefore, failures go undetected and grow over time. And in conditions like this, these signals, these very important signals are constrained, suppressed, or maybe even extinguished entirely. And so that's obviously not so good. And there's a third magic that happens. In the ideal, we have enough time in our daily work for planning, practicing, experimenting, and improving. That the highly consequential work that have the high outage costs that can't be undone, we can do them, we can learn about them not in production, but we can do that in planning and practice where we have lower stakes so that we can safely fail, learn, and improve. And we're capturing lessons throughout the process so we can get better at what we do. What's the opposite? The not ideal is that work is always having to be done in these high stakes performance environments where we have no ability to undo. And learning is an inherently experimental process that's iterative, right? And so when we can't undo, can't redo, right, we can't learn. And another aspect of not ideal is that we have no time to pause in production. We have no time to slow down, to speed up, to stop sawing, to sharpen the saw. And so these three mechanisms really explain a very large mystery, which is why are there even winners and losers at all when there is this level playing field? Whenever you look at organizations competing, they have the same opportunity, the same raw materials, same equipment, probably same suppliers, same science and technology, same technology systems, same laws and regulations. Why do decisive winners exist? And even more astonishingly, they remain winners for years or even decades at a time. Because if there were truly a level playing field, right, it should always be a tie. And so what is different? What is this magic? The magic resides in this layer 3. So layer 1 is the object of work in front of us. It could be the code that we're working on. It could be the binary running in production. It could be the patient in front of us. Layer 2 is where all the tools and technologies that we use to do that work. It could be the IDE. It could be like Kubernetes. It could be the MRI machine or the CAT scanner. But layer 3 is the social circuitry. It is how we wire our teams together. And that explains the processes and procedures of how we coordinate teams from multiple functional silos to do work to achieve a common goal. And so when we look at winners and losers, the only thing that's different is typically around layer 3. And so in the book, we say that there are these three mechanisms: slowification, amplification, simplification, and amplification. And it allows us to not operate in a very dangerous zone where work is highly complex and intertwined. We have high stakes. We have no ability to undo. Things are hard to control. Problems are hidden. And we have no ability to iterate, right? That's the danger zone. The winning zone is the exact opposite characteristics. We can work in a slower moving environment, not production, but in planning and practice. We have multiple chances at bat. The problems become more obvious. We can decompose problems so that they're safer and easier to solve. They're more controllable and again, lower stakes. And so the three mechanisms, slowification, simplification, and applications are ways that we can go from the danger zone to the winning zone. So slowification, let's not solve problems in production, but in pre-production, even pausing the system if necessary. The famous Toyota Andon cord being a famous example of that. Simplification, we take large problems. So slowification is where we move problem solving from the fast-moving production environment into slower-moving planning and practice. Simplification, we actually change the nature of the problems themselves so they're easier to solve. We decompose them into modules, or we iterate on problems, or we linearize processes that are sequential. And amplification, we want to remove noise from the system, amplify weak signals of failure so we can act upon them to better prevent, detect, and correct. So in our world, examples of slowification are things like pausing to pay down technical debt, or rehearsing high stakes and critical operations. Simplification, we will see many very familiar things like incrementalization is all about taking large problems and solving them in small batches, or we can split them up like through modules or service-oriented architecture so that we can regain independence of action, or for sequential activities like deployments and releases, right? We want to be able to tie them together like in an assembly line and linearize them. And then amplification, right? There are all these things around culture that we talk about how to bring fast feedback into all aspects of our work and make sure that even weak signal failures are amplified and acted upon. So I'll talk about each one of those in more detail. But before I do that, I want to share with you a vignette that I'm hoping that if anyone gets out of the book, it will be this one thing about Steve and Jean moving a couch. And this is really a metaphor for joint cognition and problem solving. So suppose you have two people moving a couch. Let's call them Steve and Jean. And you might think that this is all brawn work. There's no brain work required. But in fact, Steve and Jean have to solve a lot of problems. They have to figure out where is the center of gravity to get through a narrow doorway, around which axis do they need to rotate around. To get down a narrow winding staircase, who should go first and should they face forwards or backwards? And what's amazing is they don't need focus groups or a lot of consultants. Just by picking up the couch, by trial and error, fast feedback, communicating, coordinating, we can have confidence that they will be able to figure out how to solve those problems. But there are all these things that we as leaders can do to make their work more difficult. For example, we can turn off all the lights, which makes the work take longer. It might even become more dangerous. They can damage the furniture, the rooms, or worse, even themselves. And so that's obviously not so good. But there's other things that we can do, like introduce a lot of background noise, like a siren, like a loud music. And this actually introduces a different dimension of problems versus turning off the lights, is that suddenly Steve and Jean can't communicate and coordinate. In fact, we can even introduce an intermediary so that Steve and Jean can't talk directly with each other. We'll force them to go through JIRA tickets or work orders or go through account managers or even have lawyers present or regulators. And suddenly it is not so difficult to imagine that Steve and Jean will not be able to achieve their goal because their ability to communicate and coordinate has been so thoroughly disrupted. And so this is really the DevOps story, is that eventually we got to a point, 10, 20 years ago, where Dev and Ops could no longer work in a silo and achieve their goals. That only through breaking down the barriers between Dev and Ops could we actually successfully go to this higher tempo of operations that we live in now. And so this is really, I had mentioned the couch is a metaphor for coupling and coherence. Coherence is to what degree can people within the system work together in a logical and consistent behavior. And the second is coupling, right? When Steve and Jean are moving a couch together, they are inherently coupled. What affects Jean affects Steve and vice versa, and whatever affects the couch affects both of them. And this is inherently different than Steve and Jean moving two chairs independently. And so, in general, like we want things less coupled because it gives them independence of action. We can change one side of the interface without having to change the other side. So I'll bring up this couch metaphor several times in this presentation because I think it's such a powerful metaphor to explain much of what we see and believe. It's certainly been the case for me. So let me go to the first one about slowification. I had mentioned that slowification moves problem solving from the dangerous production environment into planning and practice, and often requires us to pause the system. So in the Wiring the Winning organization, we have 23 case studies, of which only 20% are technology related. And one of my favorite, and I say favorite in scare quotes because, I mean, it's actually quite horrific. There's a healthcare, 20% of the case studies are also healthcare related. I think it's actually the most number of the case studies are healthcare related because healthcare systems are so dangerous to operate in. And here's an example of why. There was a famous case called the Miss Morris versus Mrs. Morrison case, where the wrong patient got operated on, despite over 14 signals of something going wrong being detected by somebody, including the patient saying, "You've got the wrong person." And so in each one of these cases, there were evidence, that something was going wrong. That everything from the bracelet on the patient being unreadable or being incorrect, but no one acted upon it. And so, what differentiates? And let's talk about like why healthcare systems are so dangerous these days. One of the things I learned working with Steve was that actually hospitals were dramatically easier and safer in the 1950s. And one of the main reasons for this is that there were only two functional specialties. There were doctors and nurses. There were very little technology, so you didn't even have these layer two teams that introduced its own functional silos. So these days, in a modern hospital system, you have scores of functional specialties just within the doctors and clinicians. You have nurses, you have supply chain, you have pharmacy. You even have lots of these technology teams. Like it used to be called radiology, meaning X-rays, but now it's MRIs and CAT scans. So now it's called imaging. So the more functional specialties you have, the more sophisticated the layer three coordinating mechanism must be. And so this is just an amazing example of a layer three system that was inadequate to deliver healthcare safely. So whenever you see teams working in highly consequential and dangerous situations, you know that they have made investments in planning and practice, right? Because by logical argumentation, they could not have learned it all in production. And so I think one of the most famous examples in our world happened on April 11th, 2011. This April 22nd, 2011. So this was the first large-scale AWS failure that happened in AWS East. So this is their largest availability zone, still is. That's where they put their largest customers because they had the most amount of resources there. And so when that went down, basically every one of the large customers went down, Reddit, Quora, but one very strange exception was Netflix, which was very interesting because Netflix publicly claimed that they were running entirely in the AWS cloud. So how is that possible? The answer was revealed some days later in this famous blog post called Five Lessons We've Learned Using AWS, where they revealed two very surprising design decisions. One is they said as they've started migrating away from data centers into AWS, they could have no single point of failures, of which the largest they identified was AWS. They said they will never be there when you need them most, which is super interesting. Two, the second surprise was that they revealed this thing called Chaos Monkey. So of course, all of us probably know that Chaos Monkey is this audacious piece of code that runs on every server in the cloud, and it just randomly kills VMs in the middle of office hours. I used to think that, and so you can imagine these service teams that you build it, you run it. If developers are now having to deal with their services being randomly killed in production, right? They're going to get very good at making sure that they're resilient enough so they can stay up and running without any human intervention. I used to think that Chaos Monkey ran 24 hours a day. And Adrian Cockcroft, cloud architect there at the time, he said, no, 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 no. Enough things go wrong in the middle of the night. Let's not make it worse by running Chaos Monkey there. We run it only in office hours, right? Because when everyone's already working, right, they're already in a situation where they can best fix it. It's fantastic. So you can imagine, right? It's by running things like this that allowed them to ride out the AWS East outage. So what's amazing is that you can see this happen on ever greater scales. It turns out Chaos Monkey is just one of, one member of the Simian army. 2014, it happened again in the great AWS reboot. So when Christos Klantzis, the Netflix cloud database engineering lead, he said, when we got the news about the emergency EC2 reboots, our jaws dropped. When we got the list of how many Cassandra database nodes would be affected, I felt physically ill. But then he goes on to say, then I remembered all the Chaos Monkey exercises we've gone through. My reaction was bring it on. And that is amazing, right? Because of the 2,700 production Cassandra database nodes, 218 were rebooted. So it's about 5% of them, actually 1%, and 22 were bricked. They never rebooted successfully. And yet there was no customer downtime. So this did not happen by accident. This was because staying up and running was a critical business objective, and they invested time in slowification. So you might observe that slowification is not a real English word. We made it up but we use that because it is our observation that sometimes if there's not a word for something, if you can't think it, you can't say it or do it. And so there was no one word that articulated this notion of pausing, of making a shorter term investment for a longer term gain. And you're not doing it, for academic reasons. You're doing it to better achieve the most important goals, thus slowification. And so in our world, right, we know that greatness is never free. There's this need to pay down technical debt. And so just to explain technical debt and what we can do about it and how it fits into slowification, let me just tell you the story of where technical debt comes from using only up and down arrows. So think of a time when you were first to market and you would do whatever it takes to get to market. We were willing to cut corners, to build up some technical debt, take some risks, knowing that in the short term, we might drive down quality and maybe drive up the number of customer impacting incidents. But the problem is this is an incomplete story. It does not end there. If you fast forward in time, what invariably happens is that the feature rate goes down, the time spent working on defects go up to the point where it crosses over 100%. And this is exactly when defects dominate daily work. This is what tanks our site reliability. It's caused us to go slower and slower. Customers leave, engineers leave, because everything that was once easy is now hard or even impossible. And who hasn't felt this? John Cutler, famous in the product community, said exactly in 2015, a certain reference feature would take 15 to 30 days. 3 years later, same class of feature now takes 10 times longer. And so make no mistake, this kills companies. My favorite example of this is from Risto Salasma. He was the founder of F-Secure. He joined the board of Nokia in 2007, thinking that this was going to be the height of his career. And it's just one of my favorite books I've read in the last decade. It is, he described his own faults and his own inability to change the board dynamics due to a very domineering board chairman. My favorite story in the book was when he found out in 2010 that the build times for the Symbian operating system took 48 hours. He said it felt like being hit in the head with a sledgehammer because he knew that if it took 2 days for any engineer to determine whether a change worked or would have to be redone, there was a fundamental flaw in Symbian OS, of which rested on all the goals, dreams, and aspirations. And that's what actually drove them to Windows Mobile, which didn't treat them so well either, but that was actually a far better bet than staying on Symbian OS. And so make no mistake, Nokia did not make it, but every one of these tech giants, eBay, Microsoft, Google, Amazon, LinkedIn, Etsy, all of them almost died because of technical debt. But they made a very different decision than what Nokia did. And my favorite example of this is the Microsoft security stand down in 2002. Many of you might remember that this was there was this thing called the Summer of Worms, where almost every major Microsoft product was being mown down because of security vulnerabilities. And so they went into a year-long feature freeze. They published a memo internally and then published it externally, describing why they're doing this across Office, Windows, SQL Server, Exchange, and so forth. And my favorite line in this note from Bill Gates, then CEO of Microsoft, said, if any engineer has to choose between adding features or resolving a security issue, fix the security issue because the survival of the company depends upon it. And so what every one of these companies did is that they took feature rates down to 0 so they could pay down technical debt, so they could focus on quality, drive down the number of defects, reinvest in architecture that allows us to increase the productivity of engineers, often by orders of magnitude. And this is what happened in every one of those organizations. And as I mentioned in my 2019 presentation, it's not just CEOs talking about this. And rest assured, this was CEO driven in every one of those organizations I talked about, but it's product owners. Marty Kagan, who wrote the book, How to Create Products that Customers Love, his advice to every product owner, he's trained generations of product owners to take 20% of all cycles from engineering and give it back to the engineers. They are not there for product owners to spend. That's there for engineers to use however they best see fit to fix problematic areas of code, to refactor, to re-architect, whatever it takes, so that you don't spend 100% of your time paying down technical debt, which is what Marty Kagan found himself doing in the early 2000s when he was VP of product management for eBay for 3 years, he did not ship a major feature because all the engineers were spending just trying to keep the site up and paying down technical debt. So, slowification, pause to pay down technical debt, to to do drills, inject faults in a production environment like Chaos Monkey. And it's even moments where someone thinks that's odd in the middle of a deployment. That shouldn't have happened, or in a failing test. These can often be weak signals of failure that could merit slowing down or even pausing entirely, lest something terrible happen like Miss Morris versus Miss Morrison. So that's slowification, where we shift certain types of problems in time, not to do them in production, but doing them in planning and practice. The second one is simplification, where we change the nature of problems themselves. And so this should be familiar to you because in the state of DevOps research, what we found was one of the top two predictors of performance was architecture. So as measured by what? What we found was that teams that had these characteristics were predictive to be high performers. To what extent can teams make large-scale changes to their parts of the system without permission from anyone else outside of their team? To what extent can they do their work without a lot of fine-grained communication and coordination, again, with people outside of their team? To what extent can they deploy and release their service on demand, maybe even independent of services they depend upon, which is quite remarkable? To what extent can they do their own testing on demand without the use of a scarce integrated test environment, which inherently couples us to the entire enterprise, right? Because everything that we build has to be tested in the presence of everything else. If those things are true, then we should be able to do deployments during normal business hours with negligible downtime. And so just keep that in your head, because I'm going to tell you the case study of probably the most famous example of creating one of these architectures, which is Amazon. And so in 1998, life was pretty easy for the technology teams there because they were selling books and music, right? And a couple more categories. By 2002, however, they're selling books and music and 32 other product categories. So why is this a problem? So if you think about what the internal team structure of Amazon must have been at the time, you still had the e-commerce teams, a product page, shopping cart, ordering, returns, and inventory. But then you have this ever-growing number of product teams, books, music, digital apparel, and so much more. And this creates all these problems because now teams have to communicate and coordinate with ever-growing number of teams. So in the famous interview that ACMQ did with Dr. Werner Vogels, then CTO and still CTO of Amazon now, he described this absurd situation that their digital teams found themselves in. So this is Amazon Music, Kindle, Amazon Video, and Kindle. They described how those teams were in the situation where all the customers at time of purchase had to provide a physical shipping address, which didn't make much sense since there was nothing to fulfill. And he wrote there was no way around it. So these digital teams would go to 80 different ordering teams and say, we need to change this, but they would hear back, we haven't budgeted for it. And so now those teams are stuck, just like in the mobile telco company they had talked about before. And so you can see this in their deployment frequencies. In 1999, they were probably doing thousands of deployments every year. By 2001, they were only doing tens of deployments per year. In fact, most deployments did not finish because something went wrong in the CI/CD process. And so what did they do about it? Because this was depriving independence of action and teams from actually doing what they needed to get done because of the high cost of coordination. And so this is, of course, leads to the famous $1 billion Amazon API re-architecture, where Steve Yegge wrote, there are essentially 7 points to this incredible, audacious memo that Jeff Bezos, then CEO, wrote, which says that all teams must henceforth expose their data and functionality only through service interfaces. In other words, APIs. Teams can only communicate with each other through those APIs. There's no other form of inter-process communication allowed. Anyone who doesn't do this will be fired. And thank you and have a nice day. So number 7, Steve Yegge wrote, is obviously a joke because Bezos doesn't care whether you have a good day or not. This is all enforced by then Amazon CEO Rick Dalzell, former Army U.S. Ranger. And so what's remarkable in previous years, I talked about it. So what's the result of doing this? They started splitting up their services so that by 2011, they're doing 15,000 deployments per day, which shocked the world, but then shocked the world even more in 2015 when they described how they're doing 136,000 deployments per day. And so in over the last 10 years, when I talk about this, I say it's like a data center that looked like this, where code got so complected together and intertwined that it became this, which is not so good. And by creating those hard modular boundaries, it became this. But I think a better metaphor to use is the couch metaphor. By 2002, it was as if Amazon had 3,500 engineers all coupled to one couch, right? For anyone to get anything done, they had to communicate and coordinate and synchronize and prioritize with 3,500 engineers. Worse, they would potentially have to deploy with them, right? And so no one had independence of action. And by splitting up the couches into smaller pieces, they regained independence of action so they could develop, test, and deploy independently of each other. And so the words I've learned to use after this book is this notion of independence of action. We can avoid design time coupling, so changes can be made only on one side of the interface. And by these microservices, they create runtime decoupling, that we can now scale these services independently of each other. So what's interesting about the couch metaphor to me is that we can explain two very different scenarios. So the Amazon e-commerce example in 2001 was like too many people coupled to one couch. The countermeasure, you split them up into smaller couches so that each team has coherence and is decoupled from everyone else. In 2023, last year, there was another famous example, another notorious example of Amazon Prime Video, where they went for the other way. They went from microservices back into a monolith. And so that is very interesting. And you can explain that because it is as if they had divided the couch into too many small pieces, maybe even into chairs, right? And so no one had coherence. They're spending all the time coordinating and, more importantly, transporting data in and out of storage buckets. And the only way that you could talk to other services was through events. And so the countermeasure was to glue all the couches back together again to regain coherence and increase coupling, saving them a ton of money. So I love the principle of parsimony. Can you explain the most with the least? And I think the couch does a great example of that. So example, simplification, modularization is just one way to simplify. Linearization, we're familiar with that because a CI/CD pipeline, automation is just one piece of it. What it does is that it inherently links the activities of developers, testers, QA engineers, information security people, deployment people, so that they are all tied together. And linearization does for sequential processes what modularization does for parallel processes. It creates independence of action. And then you have the third one, incrementalization, is about splitting large problems in time and solving them in smaller batches. So I'll make one last note on another way that we've seen modularization creep into our work. It's not about just microservices. It's also around platform teams. So as a developer, there are so many things I hate doing now. And I basically means everything outside of my application. I hate connecting anything to anything else. I hate updating dependencies, secrets management, authentication, authorization, data masking, bash, YAML patching, writing Kubernetes deployment files, right? I can't figure out why my cloud costs are so high, right? I just want to focus on solving the business problem in front of me. And I don't want to deal with these other things. And I'm not saying that to diminish them, right? Especially when it's around security, they are as important as the feature I'm trying to build, but I just don't care about them. I would rather just solve the problems I want to solve. And what's amazing is that through platform teams, which is a form of modularization, we can do all these things self-service and on demand. And we don't have to open up tickets and bug 35 people to get what we need. We can get them immediately with fast feedback, which creates and enables focus and flow and joy. And so platform teams are another form where we can create independence of action for developers by creating these shared services that allow developers to focus on what they need to, and they don't have to be spent all the time waiting on other capabilities. So slowification is where we shift problem solving from production into the safer environments of planning and practice. Simplification is we make the problems easier to solve by partitioning them either in space or time through incrementalization, modularization, or amplification. I'm sorry, or linearization. And the last one is amplification. So I had mentioned top two predictors of performance. One was architecture. The second one was the Westrum organizational typology model. So Dr. Ron Westrum, who is as phenomenal in person as he is through his books, I learned over the pandemic when I got to talk with him over multiple hours, and he presented at DevOps Enterprise Summit, now Enterprise Technology Leader Summit. And he, by studying aviation, healthcare, nuclear reactor safety, he found that safety was highly correlated with these behaviors. In the worst organizations, we hid information. Messengers of bad news are shot. We discourage bridging between teams. We cover up failures, and new ideas are crushed. He said in the middle, we had these bureaucratic organizations where processes were there to protect people, which is good, but not as good as what he called generative, which is those where we seek information. We train messengers to tell bad news. We encourage bridging between teams because responsibilities must be shared, because InfoSec is not just InfoSec's job, just like uptime and availability isn't just opposite job, it's everybody's job. And when failures happen, it causes a genuine sense of inquiry. And so Dr. Westrom talked about how culture is difficult to talk about because it's so gossamer, it's so ethereal. And so in our book, we have a different take on culture, and we would say, how would an engineer describe this? And we use Dr. Claude Shannon's information theory, where we say this is really a property about transmission of signals, where signals must be generated, transmitted, and most importantly, received, and then acted upon and corrective action confirmed. I think one of the most remarkable things, and it was just so heady to see this happen in real time last year, as was 13 months ago, which was in the United States, we had Winter Storm Elliott hit. And basically every airline had to cancel flights. But what was so remarkable was that if you look at the graph, every airline had to cancel flights. But by the time we hit day 2, day 3, every airline was recovering except for Southwest Airlines, which is actually getting worse. And so the reason for this is that information couldn't be transmitted in layer 3 to where it needed to go. In other words, the control overlay was actually slower than the production environment. And so the reason is that what was happening at Southwest Airlines was that whenever a pilot found themselves not where they were supposed to be, either because the flight canceled or they had to divert to a different airport, they would have to call the crew scheduling department. And this had to be done by phone. And they were often on hold for hours, or in one case, 22 hours. And so if that information couldn't get into the crew scheduling system, by the time you open up operations the next day, the plane and the crew weren't where they were supposed to be. And so what was happening on the 25th to the 28th is they were essentially having to reboot their airline. They're flying these empty planes to where they were supposed to be, just like you would see in a manufacturing plant when there's an MRP failure. Sometimes you would have to shut the whole plant down for 3 days just to get parts to where they needed to go. And so we were seeing the same thing happening in real time at Southwest Airlines. And so this is often a problem in layer 3 in technology where the wrong people, the right people aren't getting the information they need, and maybe they shouldn't be getting it all. And one of the examples of this that I love so much was Adidas in 2021. Fernando Cornago, who's the VP of digital there, responsible for thousands of engineers, helping them compete in the e-commerce channel, which during the pandemic was the only functional revenue channel. He described the meteoric growth that they went through, but how after a couple of high-profile outages, he said one of the most embarrassing parts of his career was being part of 3 VPs who had to sign off on approvals. He said, what do I know about these deployments, right? I don't know anything. The people who should be making decisions are the engineers. And so in this incredible presentation, and it's this incredible hats off to the SRE teams there, described how they re-engineered the environment to make it safer so that the engineers could become responsible for determining whether a change would succeed or fail, right? And moving responsibility and decision rights down to the engineers, as opposed to the VPs who arguably have no idea whether this will succeed or fail. I'll leave you with another example. So this is a great example of amplification and rewiring the organization so that the information is in the right place, so that the decision rights could be at the right place, which is at the edge, not the core. One of my favorite examples that shows up in the DevOps handbook was this. This comes from Randy Shaup, who was engineering director at Google App Engine a decade ago. And he told me a story that I just love. He said, within Google, we love the blameless post-incident review process. Whenever there's a customer impacting outage that affects millions of customers, every Googler is waiting for the post-incident review because not only is it highly entertaining, but it could be useful to them as well. But he described this phenomenon, which is so interesting. He said, as you do these blameless postmortems, the number of customer impacting outages went down to the point where they didn't have enough to have these incident reviews around. So what did they do? They started doing blameless post-incident reviews, not after every customer impacting outage, but every team impacting incident, right? Of the 7 safeguards we had to prevent the customer impacting incident, 6 of them failed. What can we do to make sure that doesn't happen again, right? Another way to amplify very important signals so we can better achieve business goals. So I'll mention one thing about like this need for fast feedback, energetic feedback. This is why the lead time for change is so important. In other words, how quickly can we go from code committed through integration, through deployment, so that customers are saying thank you. And we want that to be measured in minutes or hours because it not only predicts, how good we are at product build, test, and deploy on the right, but it also says how much feedback are we giving to developers in their daily work. Can we give them fast feedback through automated tests within minutes or hours, or do they have to wait 9 months later during integration testing when basically the link between cause and effect has basically vanished? I would say feedback is basically non-existent in that scenario. And then it describes why there's this one question you can ask yourself that predicts with surprising accuracy everything I've talked about, which is when we do a deployment, to what degree do we fear doing them? 1 is we have no fear at all. 7 is we have existential fear of doing deployments. So we want energetic feedback loops where even weak failures of signal can be amplified and acted upon quickly. We can learn from that feedback, and the feedback's going ideally to the people doing their work so it can inform how they're doing their daily work. So to conclude, the reason why I find this latest book, Wiring the Winning Organization, so satisfying is it says so well the principle of parsimony. You want to explain the most amount of observable phenomenon with the fewest number of principles, confirm deeply held intuitions, and reveal surprising insights. And this book has done that for me so much. It explains why these mechanisms that we see in DevOps are so effective, that these same mechanisms have an analog in any great management system, whether it's manufacturing, whether it's aviation safety, and so forth. And that it really creates this magic that winning organizations have that allow organizations to do amazing things more than any single individual could ever do, that somehow liberate everyone's creativity and problem-solving capabilities. And if we don't do that, we are stuck with the opposite. We create an organization that constrains or even extinguishes entirely the full capabilities of people within them. So I will leave you with this quote. Winston Churchill said, "We shape our buildings, and thereafter they shape us." So too it is with the layer 3 management organizational wiring system, is that we shape the layer 3 wiring, and forever after it shapes us. And so the book is called Wiring the Winning Organization. It came out in over Thanksgiving in the US, November 2023. And I'm just so proud of the book. And one of the things that is a point of particular pride to me is that the foreword is written by the former Chief of Naval Operations of the US Navy, Admiral John Richardson, who's a board director for Boeing, which is going through interesting times these days, as well as Exelon and so many other great organizations. And to me, it says that, yes, the book has been resonates with some of the people I admire most in the technology leadership community, but also people, outside of the technology community, including Dr. Joel Podolny, who was former dean of Yale School of Management. So it just says that these lessons are not just important to the software community, but almost anyone managing large systems. So thank you again for allowing me to be a part of your day. If you're interested in excerpts of Wiring the Winning Organization, as well as excerpts of anything I've written, if you're interested in links to all of the enterprise technology leadership talks, there's over 1,500 talks. I'm sorry, over 1,100 talks. Just send an email to realgenekim@sendyourslides.com with subject line DevOps, and you will get an automated response within a couple of minutes. So to Lee and Tony, I think what I'm going to do is I'm now going to open up Q&A, but if you want to pop in and walk through the questions, whatever works best for you.
Yeah, sure. So there's some questions in the Q&A. So Gene, I don't know if you want to, can you see the questions in the Q&A?
I can see the Q&A, and then actually let me just pull up chat real quick.
So did you want to maybe read the questions out loud and then answer them? Does that work?
Yes. Yes. Thank you for putting the chats in. If you can put them in Q&A, I'll just start. If you have a question you put in chat, if you can put them in Q&A, that would be super, super helpful. Let's see here. So, question from Michael is: as the technology continues to evolve, how do you see the role of DevOps evolving in the coming years? Um, what impacts DevOps? How do you think AI will impact the DevOps space? So anyone who says that the job of technology leaders is getting easier or it's done, I laugh at that notion exactly because of Michael's question. Because recall that as you increase the number of functional specialties, the the work that the layer 3 coordination layer must do gets even more challenging. And so with generative AI, which by the way is amazing, right? I have not had this much fun coding in 20 years. It's just mind breaking just how much this liberates us to do more, better work. But think about like at the uh, DevOps Enterprise ETLS conferences, we a third of our talks around generative AI, and Patrick Dubois, Godfather of DevOps, was talking about how he's integrating this into his work. And he talked about how you needed to shift right dramatically, the ML ops and AI people from the very left to the very right, so they can actually have telemetry into the production environment, because they're actually fielding live queries to LLMs in production to the customers. So you have to shift dev left. You have to shift those people not just right into development, but you have to shift them all the way right into production. You have technology gaps right now. Anyway, I think it is never been a better time to be in technology, and all of these things are DevOps related. Why did we rename the conference? Because increasingly over the last couple of years, a friend of mine said, I can't get my friends to come to the conference because they don't want to go to a conference all about deployment pipelines. I'm like, oh my gosh. 15 years ago, DevOps meant how do we get dev and ops and other functional silos to work together. It was not about deployment pipelines. Anyway, so we renamed the conference to really indicate that this is really a conference about team topologies and organizational design and automation, and really about helping technology leaders succeed. Not just senior executives, but we need leaders at all levels to create great outcomes in our organizations. Anyway, thank you for that great question. Shanuka says, thank you. I've read the Phoenix Project and finished reading the Unicorn Project today. Oh, great. By the way, the Unicorn Project was a wonderful, for me, it was just a 3-year thought experiment of like, what could the worst case architecture look like? And that was such a great preparation for this book, because I think it really helped me understand like what the worst case wiring looks like. Anyway, to implement flow, locality, and simplicity, you encourage developers to have direct access to push to production and to take accountability and responsibility, as inspired by General McChrystal's team of teams. Oh, phenomenal reading, Shanuka. You also talk about having blameless post-incident reviews for psychological safety. Check. How do you strike the balance between holding people accountable and improving psychological safety? Can you give an example, please? Yeah, absolutely. One of the the seminal psychological safety case studies. The person who coined it was Dr. Amy Edmondson at the Harvard Business School. And it was actually based on a project that she worked on, I think, for her PhD dissertation. And she made this observation, is that it is in healthcare, believe it or not. They studied kind of a whole bunch of nursing teams. And the surprising discovery was this: in nursing teams that had high psychological safety, they reported more errors and more accidents, mishaps, near misses, and so forth. Right. And so in some ways, this is sort of paradoxical, right? Because you would expect kind of like, oh, psychological safety should encourage fewer accidents. And of course, the answer and the insight was no. In teams with low psychological safety, they just hide it. Right. And so, what we need is, yes, we need accountability, but we want it safe for people to talk about problems and hardships. I think one of the big learnings for me in this writing project was that really what it boils down to is that winning wiring and great outcomes in DevOps are enabled by leaders enabling people to do their work easily and well. And for that requires people to be able to say what isn't easy and what is crappy, right? And that too requires psychological safety. And so that the whole amplification chapter has some phenomenal examples of psychological safety, including the Apollo space program and some phenomenal kind of speeches that Gene Kranz gave after Apollo 1, where 3 astronauts died on top of the in the command module, to aviation safety and so forth. Anyway, so I highly, I just love it because there's some technology examples, but even more incredibly compelling case studies in many, many other industries. Thank you, Shinuka. Graham Stein writes, to what extent does this approach require to be driven by senior management? Is it futile for individuals lower than the food chain without vision from above? You know, the reason why I love the term social circuitry and organizational wiring is when we say organizational wiring, social circuitry, it's not figurative. We actually mean it literally. In an electromechanical circuit, in an electronic circuit, right? It takes something that's in abundance in one place and gets it to where it's needed in another place. And what we're saying is that, the job of layer 3 social circuitry is the same thing, whether it's requirements, decision rights, approvals, etc. And so it does expose this fact that, like, as a mid-level leader, and we need leaders at all levels, individual contributors, team leaders, and so forth, we can only control our part of the circuit, right? And so we can create this bubble, right, of that's a great place to work. We can create interfaces so that we're good to work with. But, ultimately, to affect the other parts of the circuit, we need the owners of that part of the circuit to be responsible. So I love, my answer is, these things always start as a combination of top down and bottom up. But we can always create a little bubble where you can create great environments and great wiring inside of it. That's a component of something else. And I love the fact that you don't need permission to do that. And in fact, I think the best leaders that I've met say, we as leaders, we expect you to do that, right? You don't need permission, and by doing this, you actually create the business case to do more of it. And one of the things that make me admire the DevOps enterprise community so much, the ETLS community, is that these are the people who have been promoted at a rate far higher than any other population I've studied. And so the reward is that they get asked to do more of it and impact more people and move the needle even more for the most important goals of the organization. So to the person who asked that, highly encourage you to take some risks and do what you think is right. And feel free to email me if there's anything I can do to help. Ben, other than leaving multiple copies of your new book around the office, how would you suggest I influence upper management towards proper DevOps as a lead dev on a single team? Books are great. One of the things I've always studied are the bookshelves of technology leaders, and because there's always certain books there, like the Toyota Way, The Goal, um, uh, Getting to Yes. There's a certain number of books that you always see, and I love that. More technology leaders. So many of them have IT Rev titles on them, like Phoenix Project, DevOps Handbook, and so forth. And I'm hoping Warning the Winning Organization will be another book that is a signal, right? That says anyone in who's seen that bookshelf is like, hey, these are values that I care about. So I just want to make that comment, Ben. I love the idea of book clubs. In fact, I'm talking with the CIO of Southwest Airlines, who we've been trying to connect for 2 years now. Anyway, so one of the things that they're doing is having a book club, and uh, I think it's just book clubs are a great way to talk about. I think the reason why Phoenix Project was so good for book clubs is that we're not talking about our organization. We're talking about this screwed up organization called Parts Unlimited in this fictitious novel. So I'm hoping in Warning the Winning Organization becomes also suitable for book clubs, because um, some of the case studies are just so relatable, like because they deal with medicine. And like anyone who, if I can just tell a quick story, one of those stories that's in the book was Steve, this must have been decades ago, when his daughter injured her wrist on a playground, and they went into the emergency room, waited for hours. When they finally get into the emergency department, they almost x-rayed the wrong hand, the wrong wrist, because of incorrect instructions on the work order. She had to get a plaster cast, which is instead of a fiberglass cast, which is far more kid friendly, so you can bathe them and so forth without damaging the cast. To get a next appointment, they had to call an outside line, right, that they had to find themselves. Right? So these are terrible situations that any person can resonate with, and this happens all the time in technology, right? We sort of make we show that this is actually the same phenomena in technology organizations. Anyway, so I'm hoping that these stories will resonate and will help start connecting dots. And my fondest hope is that it will help give a common language to talk about, not just within technology, but across the entire organization. And that's what the reason why I was so delighted that Admiral John Richardson gave the forward to the book, just showing that it resonated with him as an engineer and as a leader of leaders. Thank you for that great question. Maria says, any tips on how to help the team invest in re-architecting, especially for our large team, to change the culture and change the wiring of the organization? Yeah, I'm going to answer this in two ways. The one is, let's do culture first. So what I find so satisfying about the amplification chapter is that we take something that's very gossamer and ethereal like culture, and we're just saying, no, this is like an information transmission problem, right? So when we say we have a culture problem, uh, we can actually isolate it. Say, is this a problem where the signal's never even been transmitted? In other words, no one knew. Is it a problem where it's not being generated? We knew about it, but we're not generating the signal because the leader's a tyrant and everyone's afraid to share bad news. Is this an information receiving problem? That the message never got to the right person? Or is it around action being taken? Is it a prioritization problem? Or is it confirmation? It's like we think we fixed it, but the person actually asking for help, we didn't actually solve that person's problem. So I just find that to be so satisfying because it takes something that can seem very ethereal and make it far more concrete, and something that any good engineer, right, which all of you are, we can now use a different set of tools to bring to bear. That's number one. Number two is architecture. Yeah, I love for that. I think it's a different one around simplification. I think the goal is, a good diagnostic is, is it that the couch is too big and we have too many people coupled to it and we need to chop it down into smaller pieces? Or is it that the couch is too small and now we have this incredibly high coordination cost to get anything done, which is actually like the first one, and we need to actually sort of increase cohesion and change the architecture. So that brings us a different set of diagnostics to bear. Anyway, I hope that helps, and if that doesn't, please email me. Chris writes pattern. Not a question about an observation, but I love where you're going. Pattern to some of these ideas. Thinking Fast Flow by Dr. Daniel Kahneman around System 1 and System 2. Absolutely. In fact, in the slowification chapter, I didn't mention this because of time, but you're absolutely right. Slow thinking, fast thinking was the two modes of thinking as described by Dr. Daniel Kahneman, and this work was done in conjunction with Dr. Amos Tversky, who died before they could give out the Nobel Prize in behavioral economics. And we're leaning heavily on that work. We're saying that there's some types of work that you can't do in production, right? Because you have to rely on System 1, habits, behaviors, routines, biases, right? And training for anything. And during an outage, during high consequence environments, that's all you have, right? The only people in the loop, in those environments, all you can tap is those experiences and training. To do anything beyond that, you have to do it in planning and practice. This is where you do red teaming, wargaming, scenario planning, right? And so now you can activate the slower, more methodical, deliberative, creative mode, System 2 thinking. Anyway, so absolutely right. Great question. And for that matter, you get a lot of personal satisfaction out of the fact that each one of the three mechanisms are based on a work that were pioneered by some of the greatest thinkers that we've known. So slowification is based on the work of Kahneman and Tversky, which won Kahneman a Nobel Prize. Believe it or not, the work around simplification is based on the work of Dr. Robert Merton, who won another Nobel Prize for behavioral economics around the creation of option theory, which he co-won with Black and Scholes. So it's called the Black-Scholes Index in U.S. real estate. And that's really the insight there was that whenever you can defer a decision, that has value. And so if you can delay a decision to when you have more information, people are willing to pay for that. And so similarly, that's for time. The same thing is modularity, but the dimension is space. If we can enable independence of action by decoupling teams from each other, just like how we can decouple decisions today from information tomorrow, right? That creates incredible value. Anyway, and then third is based on Dr. Claude Shannon and information theory. So those are three great pillars, I think, to be resting our book on. Okay, thank you. Michael Norton asks, last question: if I were to read one other book that's that of yours, which one would you recommend and why? Yeah, I would say probably the Phoenix Project is probably the best entry point, just because it's a novel about a ops leader who has to fix his cost and due date issues and uptime issues in 90 days. Otherwise, they're gonna outsource everybody. And this is based on the famous book, The Goal, by Dr. Eliyahu Goldratt. That was a book about a manufacturing plant manager who had to fix his cost and due date issues in 90 days. Otherwise, they shut the plant down. Anyway. And then the Unicorn Project is essentially the same story retold, but from a developer perspective. So it's just I think one is for ops, one is for dev, and the nonfiction companion guide to it would be the DevOps Handbook. Anyway, so and then I would say the Wiring the Winning Organization is really showing the underpinning theory of why these work and show that how they work and across a lot of other domains. All right. Tony, with that, I think we have exhausted all of the questions. Thank you so much. While I'm waiting for Tony or Leah to come online,
Yes.
it was a delight to be here.
Thanks, Gene. That was incredible.